This is quiz number 4 of quadratics, standard form, graph average rate of change, version A. Right, this is version A. So first things first, I want to keep in mind that for the first question, we're dealing with a quadratic function, and we want to make sure we know what the standard form is before we move on. So the standard form, as we remember, is ax squared plus bx plus c. And so the thing is that we want to keep a note that this function is already in descending form, meaning we want to talk about the exponents. So we have x to the power of 2, x to the power of 1, x to the power of 0. It's already in descending form, so we already know that's in standard form. So with that being said, we can then identify what our a is, identify what our b is, and c, of course. So one thing about we want to translate this graphically, we want to keep in mind what A is and what the properties of A does. So given A, we know that if it's positive, it's facing up. If it's negative, the parabola is actually facing down. So in this case, since our A is negative, we know that our parabola is facing down, but we only have two options and both options are facing down. So therefore this really doesn't really help us that much. So we want to then utilize this next piece of clue that we learned in class, that is the C. So we learned in class that if we look at the C for any given quadratic, we know that the C is actually the y-intercept. So given we know that the C is y-intercept, all we have to do is just ignore the rest of this and focus on the C. So both options, looking at both options, we know that our answer has to be B because our y-intercept is at around 21 in this case. So remember, y-intercept is just wherever our function touches the y-axis. So it has to be B. Okay, moving on to question 2. Question 2 is asking us to find the average rate of change using the first example. So we have to use this example. Okay, so using the first example, and remember when we're trying to find the average rate of change, remember that this interval that they give us, these are both x values. It's not a coordinate pair. So I'm going to label my first x value as the left one, and I'm going to label my second x value as the right hand side one. So x1 is -2, x2 is +1. So before we move on, I want to remember what our average rate of change formula is. It's really just a slope formula. F of x2 minus f of x1 all over x2 minus x1 is equal to my average rate of change, right? So what is f of x2? What is f of x1? We have to plug in these x1 and x2s over to our function, this one, this example. So we have to plug it in there. So I went ahead and I used my calculator, and I found out that f of x2 is really just f of 1, which is 15, and I found out that f of x1 is really just f of -2, which is +3. So now that I have my f of x2 and my f of x1 and x2, I have all of the properties needed to plug in into this average rate of change formula. So now I can just substitute. This is now equal to f of x2, which is 15, minus f of x1, which is 3, divided by x2, which is 1, minus, and this is the tricky part, parentheses, x1 is actually a -2, so I'm going to put parentheses there. So this is equal to 15 over 3 minus 3, which is 12. And the bottom we have 1 minus -2. So opposites. So negative times negative is actually positive, so this becomes 1 plus 2, which is 3. 12 divided by 3 is 4, and that is my answer. This is my average rate of change for my given quadratic for this given interval. So from negative 2 to 1, from x equals negative 2 all the way to positive 1, we're looking at this interval, and it turns out that my average rate of change for this part of my parabola is equal to 4. So this is my answer. Okay. The next question is talking about the squares. We did this when Mr. Ang was absent, and I hope we've had maybe about 3 opportunities to really learn about this. So we had this in the last quiz, and this is just a really plug and then check if it works, and if it doesn't work, remember the columns all have to have 1, 2, and 3, and no repeats. Rows and columns have to have 1, 2, and 3, and no repeats. So the first one that I want to tackle is this 8. So I got to find out 3 numbers that add up to 8. The thing that I can think of is possibly maybe 3, 2, and 3, but I can't put the 3's next to each other. So I'm going to put the 3's away from each other, not on the same column and not on the same row. And that means this has to be 2. 3 plus 3 plus 2 is 8. So that checks out. The next thing I want to do is maybe find out 2 numbers that add up to 4. In this case, I'm thinking 3 and 1. 3 cannot be here because it's going to be in the same row. So I'm going to put 3 here and put 1 here. 1, 2, and 3, that checks out. Next up, I want to maybe find out what 2 numbers that add up to 3, and that's just 1 and 2. So I'm going to put 1 here and then 2 here. I put the 1 here because if I had 2 on this side, we're going to be having repeats on the same column, so that's not going to work out. So far that's good. And then this has to be 2 because I have to have 1, 2, and 3 on this column. And this has to be 1 because I have to have all 1, 2, and 3 on this column. And this checks out as well. So everything checks out. 3, same thing as 2 plus 1. So hopefully this makes sense. It's really just plugging and checking if it works out. And yeah, let's move on to the last part of this quiz. And then the last part of this quiz, they're asking us to find out, given this quadratic, they want you to really find out what the, just fill out this table values. And before you just plug in any random number, we learned in class that it's best to first start out with the vertex, specifically starting out with the axis of symmetry, and that with that we're going to be able to find the vertex and then build upon that, finding neighboring values. So let's go ahead and find out what the axis of symmetry is. So the axis of symmetry formula is negative b all over 2a, and this can be found by looking at our coefficients for our quadratic. We know that b is actually what? Is actually 8, and we also know that a is equal to negative 2, right? And now that we found out what b is, we can just substitute. So this becomes negative 8 all over 2 times negative 2. Gotta remember to put those parentheses. So this becomes negative 8 all over negative 4. Negatives cancels each other out, so this becomes 8 divided by 4, which is just 2. So therefore, my axis of symmetry is positive 2. So it's positive 2. So x equals positive 2 is my axis of symmetry. With this, we can then just plug it into our quadratic, this example, and we can actually find out what the vertex is. So if we plug it in, we come to find out that when we plug it in, we end up getting 0. So if we check it out, we now have our middle value. So our vertex is really 2, 0. So remember, vertex is actually just a point on the graph, the middle point. So we plug it in right here in the table of values. We have 2, 0. And all we have to do is just keep finding neighboring values. So anything around 2. So if I go, we find out what 1, 0 is, 3 and 4, 3 and 4. And if we plug them into our calculator, it just comes out to be, if I plug in 0, I get -8. If I plug in 1, I get -2. If I plug in 3, I get -2. If I plug in 4, I get -8. You know you did it right when you see the symmetry. So we know that 2, 0 is our vertex, so anything to the left should be symmetrical to anything to the right. So -8, -2, 0, -2, -8. Perfect. So we know we did it right. So the last thing we need to do is just graph this. And so we can go ahead and graph this. We have 2, 0 should be somewhere around here. And then we have 3, -2, somewhere down here, 4, -8, 2, 3, 4, 5, 6, 7, 8 down here. And then we have this over here. I'm just copying everything down. So we have 0, -8. And then this should be a rough sketch of our parabola facing down. And everything does match. Our parabola is facing down. And we can also take that away from the fact that A is negative. And that almost sums up our quiz. We still need to find where our domain and range are. So our domain is all of the x values. So remember, domain is x values. So the stuff that goes side by side. So notice that our domain, if we extend this parabola going left and right, we know that it's going to extend forever to the left and forever to the right. So we can actually say that our domain is -infinity to +infinity. Always the lowest value to the left and the greatest value to the right. Now the range is the y values. What's the lowest y value that we have? Well, it just keeps on going down forever. So this is -infinity. What's the highest value? The highest y value that our function actually reaches. It's at 0. So therefore 0 is the highest value. Put it to the right, and it's actually included. So we put a closed bracket. And that was the quiz solution for number 4, version A. I hope you guys found this helpful, and I'll see you in the next one. Bye.